Okay, so we are going to plot our ship's course 098 degrees true and 10 knots with the following targets as follows. So first target 1100 hours, bearing 143 degrees true and 12 miles. Then at 1106, bearing 143, the same, 10 nautical miles. Okay, to avoid collision, plan to alter course when the target is at 8 nautical mile distance to pass with 2 nautical mile CPA on your port side. Then required, find DRM, SRM, CPA, TCPA, BCPA, BCR, BCT, new DRM, new SRM, new CPA, new TCPA, new BCPA, and the new course. Okay, so let's plot the target. So 143. Okay, to be more accurate, use the line on your triangle. Then measure 12 using the 12 nautical mile scale. There. Okay, so it's a little bit outside because there is an error of printing. Then 10. Okay, also a little bit above the 10 mile circle. Okay, instead of using the pencil, I will use the ball pen to be clearer for you to watch. There. So label this as your R at 1100 hours. Then this is your M at 1106. There. So this is your RML. And as you can see, this is in collision course. That is reciprocal to your course. So we can now write your DRM, which is reciprocal of your course, that is 323. Then SRM, so that is 12 nautical miles minus 10 nautical miles. That is exactly 2 nautical miles. So to calculate for that, remember that the distance is equal to speed times time. So speed is equal to distance divided by time. So what is your distance? That is 2 nautical miles divided by time. What is your time? So that is 6 minutes. So convert it to hour. So 6 minutes divided by 60 minutes per hour. Cancel, cancel. That is 6 divided by 60 is 0.1 hour. So divided by 0.1 hour, then that will be 20 nautical miles per hour, or that is 20 knots. Then we plot our course, which is 0.98 degrees through with the speed of 10 knots. Measure 10 knots here. Of course, 10 knots is this. The distance that you will use is distance is equal to speed times time. So speed is 10 knots. Multiplied by 0.1, that is 1 nautical mile. Okay. That would be your E to R. Then transfer it here on your R. So this will be your E. So SRM is, I forgot to write, that is 20 knots. Then find your true course. So find the true course of the target, and that is by aligning E to M. And that is, or you can put decimal if you like, 348. Then let's plot the point of execution, that is according to our problem, that is when the target bears 8 nautical miles. So 8 nautical miles, measure 8 nautical miles. A little bit above the line, a little bit above the circle. Then label this as your MX. So MX is the point of execution. That is the point of alteration. Then measure 2 miles for your required CPA. So this is exactly on the circle. Then draw a tangent line from MX, tangent to the tangent to the 2 nautical mile this will be your new RML. The target speed is E to M. That is 15 knots. Then draw a line from MX tangent to the 2 nautical mile required CPA. I have already drawn the line. Then measure the new DRM. How about the CPA? The CPA is at collision point or in collision course, in collision with the target. So that is 0 nautical miles. Then the time to CPA or the TCPA there is no need to measure that, because if you measure it, that is exactly 8 nautical miles. So 8 divided by 20, that is exactly 24 minutes. So you can also approximate that, because the 2 nautical mile is a 6 minutes interval. So MX, which is 2 nautical miles from your M, is also 6 minutes. So that is already, the time is 12 hours. The CPA is 6 plus 6 plus 6 plus 6 plus 6, that is 5 times 6, that is 30, plus the time at M, which is 11:06, that is 11:36. Then what is the bow crossing range? Because that is in collision course, the bow crossing range and the CPA is equal, that is 0 nautical miles. Then how about the BCPA? Also, the bow crossing time is equal to the DCPA, so 11:36 hours. Then the BCPA, so what is BCPA? That is the bearing of the CPA from your position. So in this case, it is undefined. So you can put none or undefined. BCPA is not 143 degrees or the bearing of the targets. Although the ship is coming from there, it is not, because the rule is it should be perpendicular to the new RML in this case. Remember that the BCPA is measured in a perpendicular line with the RML, that is 90 degrees from the RML. So you cannot apply this rule. That's why this is undefined. New DRM, new SRM, and then new CPA. Remember that the new CPA is the required 2 nautical mile radius. New TCPA, and then new BCPA, and then finally the new course, or lastly the new course. Okay, so let's go back to the execution point. So we will draw a line tangent to the 2 nautical mile required CPA, then measure it on the center. So the new DRM is 338. Or you can write 337.9. But never mind, what is 0.1? Then the new SRM will be measured later. First, do not move your triangle. Then we will measure the CPA by doing like this. Okay, so this is how to measure your perpendicular line with the new RML. So this is your new CPA, and then directly above here is your BCPA, or new BCPA in this case. Then do not move. Let's return. Transfer now your new DRM to M. Then draw a line. There. So your BCPA is this. We mark it already. That is 068.5. And then write it here. Then using your compass divider, measure the 10 knot speed. Put it on your E and then draw a semicircle or an arc from your E. Then the intersection will be the R prime or R1. And then your new SRM will be from R prime to M. Here is the larger picture of the intersection, which is the R prime. To M. Then measure it. So that is 23.5 or 2.35. That is 23.5 knots. Measure the distance from your MX or the point of execution to the point of the new CPA. That is 7.8 nautical miles. 7.8 divided by 23.5 times 60 plus 12 minutes, that is 31.9 minutes. So maybe we can use 32. New TCPA will be 11:32 hours. Okay, then finally the new course. So the new course is from your E to R prime. So that is connect your R prime to E. Then put it in the middle. So your new course is 143 degrees true. So that is the same with your target's bearing. That is how you plot your new course. So see you next video. Thank you for watching.